This is SpaceTime Series 25, Episode 5, for broadcast on the 12th of January 2022. Coming up on SpaceTime, a failed Russian rocket crashes back to Earth in an uncontrolled re-entry, exploring the Jovian ice moon Europa, and TESS continues its mission searching for planets orbiting distant stars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A failed Russian TESS launch has seen a 4-ton rocket stage crash back to Earth in a fiery, uncontrolled re-entry. The burning debris from the Angara rocket Percy upper stage slammed into the South Pacific Ocean east of French Polynesia. Mission managers had no idea where or when the wildly tumbling spacecraft was going to re-enter the atmosphere and consequently where it would hit the surface. The exact dynamics of the re-entry were going to be dependent on the rate of orbital decay, the amount of atmospheric drag the spacecraft was encountering, and how evenly that drag was distributed around the planet. Even the attitude of the spacecraft as it skipped across the upper layers of the atmosphere would have played a part. After 9 days of uncontrolled spaceflight, the Percy with its payload still attached re-entered the Earth's atmosphere as a brilliant fireball, hitting the ocean shortly afterwards. The mission had originally launched from the Plesetsk Cosmodrome, 800 kilometers north of Moscow. The flight was the fourth test of Russia's new Angara heavy-lift rocket. Named after a Siberian river that flows out of Lake Baikal, the Angara is designed to replace the aging Proton as Russia's new heavy-lift launch vehicle. And this flight was also designed to test the new Percy upper stage booster, which would carry the flight's dummy payload from low Earth orbit up into a high geostationary transfer orbit. While the Angara's 4 strap-on boosters, core stage and third stage, all performed nominally, the Percy upper stage failed to reignite for a planned second engine burn, leaving it, with its dummy payload still attached, in a useless out-of-control orbit. Mission managers weren't even sure if the Percy had vented the remainder of its 16 tons of rocket fuel. Luckily, the debris came down in the ocean, but it could have been so much worse. Moscow's faced major cleanup builds on past failed missions, with highly toxic hypergolic fuels contaminating vast areas, and spacecraft debris crashing near villages. In 1996, Russia's failed Phobos Grunt Mars probe crashed to the ground in Chile and Argentina. The worst ever radiation spill from a crashed spacecraft was back in January 1978, when the nuclear-powered Soviet Union Cosmos 954 satellite crashed over southwestern Canada. Development of the Angara launch system began exactly 30 years ago, following the collapse of the former Soviet Union. The 47-metre-tall launch vehicle is designed to carry 24.5 tons into low Earth orbit and almost 8 tons into geostationary transfer orbit. The suborbital maiden flight of the core stage took place in July 2014, with the A5 version, that's the one with the strap-on boosters, undertaking its first orbital flight in December of the same year. The only other Angara flight was in December 2020, when a Briz M upper stage was added to the stack. This is SpaceTime. Still to come, NASA's Europa Clipper mission to explore the Jovian ice moon Europa, and TESS continues its mission to search for planets orbiting stars beyond the Sun. All that and more still to come on SpaceTime. Back in 2005, images of a brilliant watery plume erupting from below the surface of Saturn's ice moon Enceladus captivated the world. The giant geyser of vapor, ice particles and organic molecules spraying out of the moon's South Pole Tiger Stripes region suggested there must have been a liquid water ocean below Enceladus's icy crust. The discovery thrust Enceladus, as well as other worlds in the outer solar system with no atmospheres and far from the heat of the Sun, towards the top of NASA's list of places to search for signs of life. and scientists are now preparing for a mission to one of these ice-covered ocean worlds, one which may also have plumes erupting into deep space, the Jovian ice moon Europa. Scheduled for launch in 2024, NASA's Europa Clipper mission will study the moon, trying to determine whether it would have the ingredients to make it a viable home for life beyond Earth. Like Enceladus, Europa is geologically dynamic, meaning that both ice-covered moons generate heat inside as their solid internal layers are stretched and flexed by the gravitational pull of their host planets and neighbouring moons. See, it's friction from these gravitational tidal forces rather than heat from the sun, which prevents the water in these worlds from freezing solid. The heat may also help produce or circulate life's chemical building blocks on their seafloors, including carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfur. After all, the hydrothermal vents along the mid-ocean ridges on Earth's seafloors are teeming with life, and many scientists speculate it may even be where life on Earth began. Europa Clipper scientist Leanne Quick from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says a lot of people think Europa is going to be a sort of Enceladus 2.0, with watery plumes constantly spraying out from below the surface. But that's not the case. Europa is a totally different beast. Observations from NASA's Galileo mission in the 1990s, as well as images by Hubble and large Earth-based telescopes, have reported detections of faint water plumes, or at least their chemical compounds, in Europa's thin atmosphere. But no one's really certain. Now, astronomers are drawn to plumes for several reasons. Firstly, they offer scientists easy access to Europa's interior, a way to get samples of the moon's global subsurface ocean without needing to drill through more than 25 kilometres of solid ice sheets. Now, compared to Enceladus, which is the size of Texas, Europa is only slightly smaller than the Earth's moon, about a quarter the size of Earth itself. And the evidence suggests Europa has a far deeper saltwater ocean than Enceladus, possibly somewhere between 60 and 160 kilometres deep. That means it contains 2 to 3 times as much water as the Earth's oceans. And some scientists hypothesize that Europa's oceans could be reacting with superheated rocks below its seafloor, possibly through hydrothermal vents, just like on Earth. Scientists say there could also be large pockets of melted water in Europa's ice shell, which are more likely than the ocean to be a source of the plumes. And these melted water pockets could produce cozy habitats for life forms. Because it's much closer to Jupiter than Enceladus is to Saturn, more heat's generated at Europa from friction produced as it circles its host planet. Now, given that internal heat stimulates geological activity on rocky worlds, Europa is expected to have more extensive geology than Enceladus. Some scientists predict that Europa has plate tectonics. These would shift and recycle the ice sheets that make up the moon's surface. Now, if so, Europa could be circulating nutrients produced on the surface by radiation from Jupiter, such as oxygen, to pockets of liquid water in the ice shell, or perhaps even down to the ocean itself. Through the Europa Clipper mission, scientists will have a chance to test some of their hypotheses by analysing the chemical makeup of the plumes or traces they leave behind on the surface. Mind you, the European plumes, if they exist, might well be hard to detect even close up. They may be sporadic, and they may be really small and thin, given that Europa's gravity, which is much stronger than Enceladus, would likely keep these water plumes close to the surface. So, that means a drastic departure from Enceladus' spectacular geysers. Still, Europa Clipper scientists are devising a variety of strategies to find active plumes once the spacecraft begins exploring the Jovian ice moon in 2031. That's just 9 years away. We'll keep you informed. This is SpaceTime. Still to come. NASA's Transiting Exoplanet Survey Satellite TESS now well into its extended mission, and Russia's latest space tourists return home. All that and more still to come on SpaceTime. NASA's Transiting Exoplanet Survey Satellite TESS is now well into its 27-month extended mission, having already identified more than 2,600 candidate exoplanets, that is, planets orbiting stars other than the Sun. TESS searches for exoplanets using the transit method, and it covers an area 400 times larger than that surveyed by its predecessor, the planet-hunting Kepler Space Telescope. TESS was launched on April the 18th, 2018 aboard a Falcon 9 rocket and placed into a highly elliptical 13.7-day orbit with an apogee of over 400,000 kilometres, which is approximately the distance to the Moon, and a perigee of 108,000 kilometres, 3 times further out from the Earth than geostationary satellites. The spacecraft's primary mission was to survey the brightest stars near Earth for 2 years, looking for transiting exoplanets. The 362-kilogram satellite uses an array of wide-field cameras to perform a survey of 85% of the sky. To search for exoplanets, TESS watches a 24 by 96-degree section of the sky for 27 days at a time. Some of these sections overlap, so some parts of the sky were observed for almost a year. TESS concentrated on stars within 300 light-years of the Sun, watching for transits. That is, periodic dips in the brightness of a star caused by an object, say a planet, passing in front of the star as seen by TESS. With TESS, it's possible to study the mass, size, density and orbit of a large cohort of small planets, including a sample of rocky planets in the habitable zones of their host stars. The habitable zones are those areas around a star where it's not too hot and not too cold, but just right for liquid water, essential for life as we know it, to exist on a planet's surface. TESS provides prime targets, which are then examined in more detail by Hubble or ground-based observatories, and soon by the James Webb Space Telescope. While previous sky surveys with ground-based telescopes have mostly detected gas giants, and Kepler's Space Telescope has mostly found planets around very distant stars, too faint for characterization, TESS finds many small planets around nearby stars in the sky. Now, to qualify as an exoplanet candidate, an object must make at least 3 transits in the TESS data. It then passes through several additional checks to make sure these transits are real and not false positives caused by an eclipse or a companion star. TESS began hunting for exoplanets in the southern sky in July 2018, while also collecting data on supernovae, black holes and other phenomena in its line of sight. After completing the southern portion of its initial survey in July 2019, TESS began searching the northern skies, completing that survey in July 2020. It then began its extended mission, which includes a new set of target stars, increased frequency imaging, and observations of regions nearer the ecliptic. This report from NASA TV.
TESS, the Transiting Exoplanet Survey Satellite, is NASA's newest planet hunter. With mountains of data to analyze, scientists have just scratched the surface of what they can learn using TESS. Here are some noteworthy discoveries from TESS's first year. In September, the TESS team released the first of 26 planned sector images. Each sector is a 24 by 96 degree strip of sky monitored by TESS's 4 cameras. By the end of 2018, TESS began delivering on its promise to discover new worlds around nearby bright stars when astronomers announced the mission's first new exoplanets. In April 2019, 1 year after launch, astronomers announced the discovery of TESS's first Earth-size exoplanet. Orbiting a relatively nearby star, this world is likely too hot to support life, but it proved that TESS could find small planets that orbit very close to their stars. TESS has now found several multi-planet systems where small planets orbit nearby stars just as it was designed to do. Many are not in the habitable zone, like the planets in the L9859 system, but all are teaching us more about the wide range of planets out there. Even before starting its hunt for exoplanets, TESS was making observations to test its cameras. In late July 2018, TESS imaged a passing comet, along with many asteroids in our solar system. Later in the year, TESS went from seeing comets orbiting our sun to comets orbiting other stars. Its cameras spotted fluctuations in light from the star Beta Pictoris that are now recognized as the signatures of 3 comets passing in front of the star. They join planets already discovered in this young nearby system. Although designed to look for exoplanets, TESS also spots many supernovae, bright explosions that mark the deaths of stars. Its cameras can catch these outbursts from their very start, even before ground-based surveys identify them. TESS has already expanded our understanding of new worlds close to home and exploding stars beyond our galaxy.
This is SpaceTime. Still to come, Russia wraps up its latest space tourism mission, and later in the science report, a new study looks at why people binge out on TV. All that and more still to come on SpaceTime. Two Japanese space tourists and a Russian cosmonaut have returned safely to Earth aboard their Soyuz MS-20 capsule. The trio landed on the windswept Kazakhstan steppe 3.5 hours after undocking from the Zenith port aboard the International Space Station's Poisk module.
The two spaceflight participants closing hatches along with the Soyuz commander Alexander Misurkin, saying goodbye to Anton Shkaplerov, the Expedition 66 commander, and all three crew members there waving goodbye to their short-term crewmates.
SSVP mode is no longer illuminated, and we confirm physical separation. Combined GSO and GSO 1 and 2 are there. We are standing by for the first separation burn. I am standing by for the first burn, separation burn, and that's where the Rabota comes up. Operation depot of thruster firing confirmed, and we confirm the maneuver.
Goodbye station. Yeah, goodbye station. Hope to see you soon again. Выполнили разворот.
We are done with the maneuver.
Принято, наблюдаем.
Copy, we see that.
Через 40 секунд ожидаем.
And in 40 seconds, I'm standing by for the second separation burn. Copy.
Есть работа ДПО.
Thruster firing confirmed.
Принято, есть работа ДПО. Работа ДПО погасла.
Thruster firing is no longer illuminated. We are done with this burn.
The space tourists have been on a 12-day adventure to the orbiting outpost. The Russian Federal Space Agency Roscosmos says bad weather and frigid conditions delayed the helicopters from reaching the landing site after touchdown. However, all three appeared to be in good health and in good spirits in their Soyuz launch and re-entry spacesuits when they were finally assisted out of the Soyuz capsule.
Okay, and we are now receiving that the recovery crews are with the Soyuz. They arrived at 9:33 p.m. Central Time on site, the landing site, and the crew is feeling good. The descent module is vertical. May not get a final landing, exact landing time, but it was scheduled for 9:13 p.m. Central Time, and once again, we do have confirmation now that the recovery teams are with the Soyuz. It did land upright and it's in its nominal position. There is possible for it to land on its side, and that's not a problem, but this will hopefully speed recovery efforts along a little bit. Again, the recovery crews and those Mi-8 helicopters and the all-terrain vehicles have made it to the Soyuz's landing site and should now be working on extracting the crew from their Soyuz vehicle. Again, wrapping up 12 days in space, 189 orbits, and 4.6 million miles that Saku Mizawa and Yozo Hirano have traveled in the course of their flight. Led by Soyuz Commander Alexander Misurkin, who was making his third trip to space, he is wrapping up this trip with 346 days spent in space.
Space Adventures, the company that brokers space tourism flights with Roscosmos, hasn't disclosed how much the flight cost the tourists. But we know the first space tourist, Dennis Tito, paid around $20 million for his 7-day adventure to the space station that was aboard Soyuz TM-32 back in mid-2001. And we know Russia charges NASA between $60 and $90 million for a seat on a Soyuz flight. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the amount of rainfall in the Arctic may increase at a faster rate than previously thought. The findings, reported in the journal Nature Communications, show that the total rainfall could supersede snowfall in some parts of the Arctic by 2060, decades earlier than expected. The authors argue that more stringent climate mitigation policies are required, as a rainfall-dominated Arctic would have impacts on ice sheet melting, rivers and wild animal populations, and it would have important social, ecological, cultural and economic implications. Northrop Grumman has started work on the first of Australia's new MQ-4C Triton high-altitude aircraft. Based on the original Global Hawk, the new long-range reconnaissance and surveillance drones will have the same intelligence-gathering capabilities as the US Navy's new Tritons, which are now being commissioned into service. The first Australian Air Force Tritons should be flying in Aussie skies by 2024. A new study claims that the desire to escape boredom is the main reason people binge-watch TV on streaming services. The findings, reported in the journal Frontiers of Psychiatry, suggest that people with a lack of impulse control or forethought are more likely to binge-watch TV at problematic rates. Researchers surveyed over 600 people aged 18 to 30 who have watched more than one episode of a TV show in a single sitting. They say that people with impulse control difficulties, a desire for escapism, and those looking to avoid loneliness were more likely to binge watch, with 1 in 5 saying they'd watch between 6 and 20 episodes in a single sitting. The researchers say more studies are needed to draw a line between healthy and unhealthy binge watching. The world's largest consumer electronics show, CES, has provided us with another glimpse of the future of technology. While somewhat reduced in size this year thanks to COVID, the best of tomorrow's gadgets were still on display at the show in Las Vegas. This year's highlights included the latest in AK flat screens, a robotic chef that cooks gourmet meals identical down to the molecular level with the finest recipes, a battery-powered mini projector that plugs into your smartphone to display pictures or movies anywhere you want. There was a holographic device for three-dimensional communications, a car that can change colour, and an autonomous robotic tractor that does all the work for the farmer. With the details, we're joined by technology editor Alex Zaharov-Reut from ITWire.com, who's at CES.
Samsung has a remote control, for example, that not just is solar powered with ordinary batteries as well inside, but it can harvest energy from the radio frequency from your router, from Wi-Fi. And that is something we'll see in more phones and other devices over the course of this decade. I saw a company here called Energous, which makes a RF transmitter for wireless power, and at the moment, these things are for smaller devices. They don't have it ready yet for phones. We did actually see Motorola and Lenovo show a demo in 2021 of this technology at work, but if you walked in front of it, the charging stopped. Now, there's Doosan Bobcat. It's a Korean company that bought the Bobcat brand, and they have the world's first fully electric Bobcat unit. And instead of just having hydraulic attachments to pick up dirt and to move things around, this is all electric based with, I think there's actuators, and so there's no hydraulic fuel. You have 1 quart of some sort of oil as opposed to 57 gallons of hydraulic fluid that would have to be used. It's using electricity rather than diesel, and can give you 4 hours of constant non-stop use or 8 hours of a sort of normal usage. And they actually use a transparent OLED. So the screen in front of you that you look out of, your windshield as such, is actually the control center for the unit. Now, obviously, you have steering wheels and other things in front of you to control things, but you have all this digital information that would otherwise be on an LCD screen. But here it's actually on the front of the screen itself, transparently, like something out of a science fiction, like something out of a science fiction movie. So you're tapping the screen, you're tapping these icons, and you can imagine that this is the sort of thing that would be used in future moon buggies. Clearly, this sort of technology would be perfect to use on Mars or on the moon, where you're not going to have easy access to hydraulic fluid. You'll have plenty of access to solar energy to recharge things and to run around, and you have that industrial kind of design and capacity that you would need for a moon mission or a Mars mission. There was a thing called a Cubo, Q-U-B-O-O, which launched a couple of years ago. It's like a cat that sits on your lap with a tail, but it has no legs and no head, and it sort of wags its tail and moves around, and it's great for older people in homes and people that want to have a pet but can't have it.
Yeah, headless cat, that's what everyone wants.
I know. I mean, personally, I prefer the real cat, but of course, does it need to have the cat litter changed? For certain people, it does provide a level of comfort that otherwise they wouldn't get, even though it's artificial and doesn't do much more than just wriggle around and wag its tail. But, they've been successful with that. And they have another product, which is like it looks like more like an actual cat or a little bear. And you put your finger in its mouth.
I saw that, yes.
And it is sort of jet. When I put my finger in its mouth, and it's sort of jet. You feel it's like sucking on your finger. It's not. It's got some sort of motor in there that is sort of pushing down. And it's just one of those things where, for some people it's completely useless. You would never do it. But one of the staff members of the organisation said, well, they missed their little child doing that to them. And I don't know, this is a product that they've put out there. It's had an interesting response. They're going to make it. We're going to see these devices become a lot more realistic. I mean, another gadget that I saw was this human body, and it was designed for kids. It didn't have an app. but you could pull all of the body parts out, the intestines, the lungs, you could pull the legs out. You could have all these different parts of the body. You could pull the two hemispheres of the brain out. And they had a little pad. And you could put the body part on the pad, and the pad would then tell you what that body part was, and it would tell you interesting facts about different parts of the body. And it was screen-free, required no app, something that teaches young kids, about the anatomy of the human body.
From what you've seen so far, what was the thing that gobsmacked you, the thing that you thought, wow, this is really cool?
Look, the Bobcat that was fully electric with the touchscreen transparent display. The touchscreen transparent display reminded me of the phones that you see in the sci-fi TV show The Expanse, which look like iPhones.
I know that one, yep.
I did read about LG having transparent displays before I came to CES, but when Bobcat was talking about it, they said, well, that worked with LG and the new transparent display technology. So here was a practical application, because otherwise, why would you want your TV to have a transparent display? You wouldn't, because you would see the back of the wall and all the cables that are plugging into the back of it. But here was a perfect application that transformed the windshield into a useful touchscreen that is not impeding your view and is delivering real-world benefits to the user. So, one of the things that Bobcat was able to allow you to do was control other Bobcats in other parts of the country through 5G. So you can control multiple units from the one unit you're sitting in through remote control and through the low latency that 5G provides. So this enables you to have not only a faster control without the repair costs and all the moving parts, but also delivers a very quiet experience. I think they were saying 10 times quieter than your traditional diesel-powered equipment.
The question I always ask about CES is, do they have an affordable flying car? Because I'm really waiting for my flying car. Forget the hoverboard. Yeah. I've given up on that. It's the flying car. Where are we at?
The biggest thing that's going to be a problem for the flying car is the ability to get the regulatory approval for you to fly it. Because if you fly it and you accidentally crash, you're going to land in somebody's house. And that's why we don't have flying cars yet. Besides the fact they're expensive and they're noisy and they haven't got the form factor right. And, of course, you need to have the right sort of fuel. Can't really trust electric technology to have enough power. I mean, they have had drones that were flying taxis, and that's using 8 or 9 rotors or whatever it might be. So the flying car, there's been a lot of talk about that for the last 40, 50 years since we've had the Jetsons.
I think George Jetson was born in 2022.
Well, if that was the case, I mean, he's probably 30 or 40 in the TV show, so we've still got a few years, if not decades, to go before flying cars truly become something affordable and reliable and safe enough that you won't have people who are drunk or otherwise, having a medical episode or something, crashing their flying car into your house, which would be a terrible, terrible thing to have happen.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.